Here is the first video in a two-part series talking about binomial probability distributions. Previously, you learned about what a probability distribution is and the requirements to have a probability distribution. There are three requirements. The first, you need a numerical random variable x, and its values are associated with probabilities. The second requirement, if you add up every single one of these probabilities in the distribution, your sum should be approximately 1. And the third condition, each of these probabilities for every individual value of the random variable has to be in between 0 and 1 inclusive. Well, we're going to expand upon what a probability distribution is and talk about specifically binomial probability distributions. A binomial probability distribution results from a procedure that meets all the following requirements. There are 4 of them. First being the procedure has a fixed number of trials, and a trial is a single observation. This fixed number is typically denoted by a lowercase n. The second requirement, the trials must be independent of each other. And what that means is the outcome of any individual trial doesn't affect the other probabilities in the trials. The third requirement, each trial must have all outcomes classified into 2 categories or outcomes. We typically refer to these 2 categories as either a success or a failure. The probability of a success is denoted by a lowercase p. The probability of a failure is denoted by a lowercase q. And when we add these 2 probabilities up, we should always get a sum of 1. So the probability of success plus the probability of failure equals 1, or p plus q equals 1. The fourth requirement, the probability of success must remain the same in all the trials. So let's look at an example. The procedure is rolling a single 6-sided die 30 times. So let's discuss why this is a binomial probability distribution. Well, does it have a fixed number of trials? Sure. N is 30, right? We roll it 30 times. Each roll would be a single observation or a trial. Are the trials independent of each other? Yes, they are. My first roll doesn't affect my second roll. Or are these outcomes classified into 2 categories? Well, when I roll a single die, I have 6 different outcomes that could occur. I could roll a 1, a 2, a 3, a 4, a 5, or 6. But I could classify them into 2 categories. For example, I could say my success would be rolling a 2, and my failure would be, let's say, not rolling a 2. So let's discuss the probability of success. If I call my success rolling a 2, then the probability of rolling a 2, well, I have 1 2 out of 6 different options. So my probability of success, which I would denote with a lowercase p, is 1 out of 6. What about my probability of failure? Well, if my probability of success is rolling a 2, my probability of failure is rolling any other number besides a 2. We could say not rolling a 2. So the probability of failure is equal to the probability of not rolling a 2. Well, there are 5 numbers that are not 2s, so 5 out of 6. That's my Q. If I add these up, I get 1. And of course, each time the dice rolls, the probability of me rolling a 2 always remains the same. It's always a 1 out of 6. So this is an example of a binomial probability distribution. So let's look at how to calculate some of these. So an example. A student is given a surprise multiple choice test. There are 20 questions. Each question has 5 choices, and one of those choices is correct. So is this a binomial probability distribution? Well, it's got to meet those 4 requirements. The first requirement, the procedure has a fixed number of trials. Does it? Well, yeah, there's 20 questions. Each question would be a trial or a single observation. Or are these trials independent of each other? Yes, sure. The outcome of answering question 1 doesn't affect the outcome of question 2. So these are independent. Requirement 3. Each trial must have all outcomes classified into 2 categories. Is that the case? Sure, I can talk about each trial or each question. My outcome is either I get it right or I get it wrong. I either get it correct or incorrect. So, what is my probability of success or my probability of getting it correct? Well, my probability of success or getting the question correct, well, each question has 5 choices and only one of those choices is correct. So that's 1 out of 5, or as a decimal, 0.2. So that's equal to P. My probability of success in a single trial or answering a single question is only 20%. What is my probability of failure? Well, one of those choices is correct. That means the other 4 are incorrect. So the probability of failure, which is equal to the probability of getting the question incorrect, is 4 to 5, which is 0.8. And as a decimal, and that's what we're going to call Q, a lowercase q. Once again, you add these two up, you should always get a sum of 1. So we have it classified into 2 categories. Third condition or requirement is met. The fourth requirement, the probability of success remains the same in all trials. Well, each time I answer a question, I always have a 20% chance of answering it correctly. So let's move on. Question 2. What is the probability of getting exactly 7 questions correct? So this is asking for a very specific number of successes, right? I want exactly 7 correct. So when you're asking for a very specific number of successes, you're going to use what we call binomial PDF to calculate the probability. So the probability that X is equal to 7, exactly 7 successes, we're going to use what we call binomial or binom PDF. The first thing you're going to put in is your N, your fixed number of trials. Next, your probability of success, which is P. And lastly, I'm just going to call it K. That's how many successes do you want exactly. So in this case, binomial PDF, how many trials do we have? Well, we have 20 questions. What is our probability of success in a single question? Well, 0.2. And exactly how many questions do we want to get correct? Exactly 7. So I always say exact number. We're using a very precise number of successes. We use binom PDF, P for precise. Let's see what that's equal to. So to go and calculate it in the calculator, you press second, and to open up that distribution menu, you press this button here, vars, which stands for variable, and you scroll all the way down to A. Press enter. And then I already have some information typed in, but I'm going to go ahead and clear it out. You put number of trials. We have 20 questions. Your probability of success in a single trial, 0.2. And our X value is how many questions do we want to get correct? Well, exactly 7. Press enter, and enter one more time. And you end up with about 5% chance that this occurs, so 0.0545, rounding to 4 decimal places. So that's the correct answer for this question. So next question, what is the probability of getting exactly 11 correct? Well, once again, we're looking for a very precise number of successes, right? Exactly 11. So we're going to use binomial PDF. you put in first that fixed number of trials, which is 20. The probability of success in a single trial is 0.2, and exactly 11 questions. So go back to the calculator and go ahead and clear this out. Press second, open up that distribution menu by pressing this button here, and scroll all the way down to A binomial PDF for a precise value. And the only thing that's going to need to change is the X value. Instead of exactly 7, we want to know exactly 11. So type 11 in, press enter, enter, and enter again. And so what this gives you is 4.6168, so on, a bunch of numbers, E negative 4. This E means scientific notation, and this negative 4 basically means you have to shift your decimal 4 places to the left. So when you do that, you're going to end up with 3 zeros in front of that 4. And I'm just going to put a dot, 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 because you're going to have to round this number. So that's 0.0005. When you round that 4, it becomes a 5. And so that's your probability. Very small probability. And so the last one, what is the probability of getting exactly, and I already have this one written out, exactly 3 or 4 questions correct? Well, this word or, remember, that means we're going to add the probabilities. So exactly 3 or 4 questions correct. So what that's saying is that I have exactly 3 or 4 successes. So we're going to be adding first the probability that we have exactly 3 correct plus the probability of exactly 4 correct. So you're going to have to calculate 2 separate probabilities here. So I'm going to first go in and type in the first one. So open up that distribution menu and go down to Binomial PDF. Once again, nothing changes but that last one, that X value. We're looking for exactly 3 successes. Press enter, enter, and enter. And so you end up with 0.2054, so about 20%. And then calculating the second one, open up that distribution menu again, go down to Binomial PDF for a precise value, exactly 4 successes. And once again, you're just changing that X value to a 4, press enter, 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 and you end up with 0.2182. And then add up those probabilities. The sum is 0.4236. So about 42% probability that you get exactly 3 or 4 questions correct. So almost 50%. So that's it for this video. There's going to be a second video to continue our discussion dealing with binomial probability distributions. Thanks!